Logic is a powerful tool we use every day, especially when solving problems and making decisions. In this role play, students will explore different types of logical statements: the conditional, converse, inverse, contrapositive, and biconditional. Through a fun and relatable classroom mystery, students will learn how to use reasoning in real-life situations and in mathematics.
In logic and mathematics, we often deal with statements that describe relationship between two ideas or events. These are called logical statements, and one of the most common forms is the conditional statement. First is, what is a conditional statement? A conditional statement is written in the form if P, then Q. P is called the hypothesis, while the Q is called the conclusion. For example, if it rains, then the ground will be wet. This means that the rain causes the ground to wet. Second is the converse. The converse of a conditional statement switches the hypothesis and conclusion. If Q, then P. Example, if the ground is wet, then it rains. And always remember, this may not always be true. It could be also be wet for another reason. And third is inverse. The inverse negates both the hypothesis and the conclusion. If not P, then not Q. Example, if it doesn't rain, the ground will not be wet. And this might also not always be true. Someone could water the ground.
Number 4. The contrapositive switches and negates both parts. If not Q, then not P. For example, if the ground is not wet, then it did not rain. Number 5. Biconditional. A biconditional statement is used when both the condition and its converse are true. It is written as, for example, a figure is a square if and only if it has 4 equal sides and 4 right angles.
So here is the overall conclusion. Conditional, if P, then Q. Converse, if Q, then P. And inverse, if not P, then not Q. And next is the contrapositive, which is if not Q, then not P. And lastly is the biconditional. P if and only, not if only if Q. Again, biconditional, P if and only if Q. These logical tools help us form a valid argument, analyze situation, and solving problems in both mathematics and everyday reasoning.
Good morning, class. Today we're solving a mystery, and at the same time we are learning about the conditional and the biconditional and related statements. So, are you ready?
Yes, Teacher Reyes.
Okay, so let's say someone's homework is missing, and we're going to figure it out using logic.
Oh no! Whose homework?
Hey, can we use if-then statement to solve this?
Exactly, Leah. That's called a conditional statement. It has a hypothesis and a conclusion. So let's say, for about example, if a student didn't bring homework, then it is missing.
I think that might be. Test the logic. If Ben forgot his homework, then if it is missing. So the hypothesis is Ben forgot his homework, and the conclusion it is missing.
You say the opposite too?
Good thinking. That's the converse. If the homework is missing, then Ben forget it. But is that always true?
No, anyone's homework could be missing. That statement isn't it always valid?
Exactly. So the converse is not always true. Let's try the inverse now. If Ben did not forget his homework, then it is not missing.
What if I did forget? Oh no!
We test the contrapositive. If the homework is not missing, then Ben did not forget it.
This is like being logic detectives.
Yes, and when conditional and converse are both true, we can combine them into the biconditional statement.
So, like Ben forgot his homework if only if his homework is missing.
Perfect! That's a biconditional statement.
Wait! What if I left in my locker? Then the logic falls apart. The biconditional wouldn't be true.
Exactly. A biconditional only works if both forward and reverse are always true.
Cool. So now we've used conditional, converse, inverse, contrapositive, and biconditional.
Right! And this logic can help us with math, science, or even everyday decisions.
I admit it. I forget my homework, but at least now I understand logic. If Ben learns about logic, then it was a good day.
And the converse is also true.
So now, class, let's say all together, logic wins again.
Logic wins again.
That's all for today, so class dismiss.
Bye, sir.
Through this role play, students learn that logic is not just a math skill, it's a life skill. By understanding how conditional and related statements work, they can better reason, communicate, and make thoughtful decisions, whether it's solving a classroom mystery or evaluating cause and effect in real life. Logic helps us think clearly and critically.